Started. So the fourth of 5 class sessions on Module 1. And again, the theme of Module 1 has been strategic thinking. And then, so we have one more class session next week on that. And then once we can learn to think strategically, hopefully we can move into Module 2, which is strategic planning. And so there's 2 things that I'm focusing on from a strategic thinking standpoint. One is innovation engineering. So we've hit that in different aspects the last 3 weeks. Mainly I hit that early because I wanted to give you tools that you can go ahead and be using in the ideation phase of your project. And then the other thing that will help us with systematic strategic thinking is the 5th discipline, and the 5th discipline of the 5th discipline is systems thinking. So we're going to revisit that tonight and really get into some of the nitty-gritty pieces of the 5th discipline, covering 3 different chapters. But chapter 5 kind of introduces the idea, the concepts, the mechanics of systems diagrams and the language of systems thinking. Then 6 and 7 just talk about some applications of that and how to start to recognize generalities in nature, so that we can learn from nature's templates to apply them to more specific situations. And then at the end, we won't really go into the 2 other books of the semester, but I wanted you to go ahead and start reading so I could spread some of the reading out. So the readings from this week involve reading a chapter or so from the other 2 books that we're going to get into, Getting the Right Things Done, which we'll get into in Module 2, and then When They Win, You Win, which I will introduce next week. And they both have their merit on their own. So that's my goal for tonight, is to hit on chapters 5, 6, and 7, introduce the systems diagrams and the systems thinking language and what that means and how we can use that to start to visualize the big picture cause and effects, and then introduce the other 2 books. So in systems thinking, the whole goal is to get us, and again, the 5th discipline is the art of a learning organization. And the 5 disciplines that are covered in the book are basically saying these are the 5 technologies or the 5 disciplines an organization needs to have and master. And if you master all 5 of them, then the chances that you are able to establish a learning organization are much greater. And so systems thinking is one of the 5 disciplines. We hit on it a little bit with the learning disabilities, the laws of systems thinking, and then we'll introduce the mechanics of systems diagrams this evening. But it's to get us to thinking about the world not as linear events, specific, isolated events that happen that are seemingly unrelated. That's the easy way to look at things. That's if we react emotionally by seeing the tip of the iceberg without digging and asking questions of what might be happening underlying. See that in the news all the time, right? This happened. I'm not even going to associate what might have led to it, but this happened. I want to react crazy to it because I don't want to think. Then if we start to think, instead of direct, linear, independent cause and effect events, life usually happens more in circular interrelated events where every cause actually also becomes an effect for something else. Remember, one of the laws of the 5th discipline was today's problems often come from yesterday's solutions. And I thought about that multiple times this week and last week as I was dealing with different things that have popped up. And so things are usually interrelated. It's just a matter of the recency in time between that cause and effect that drives a lot of times our ability to associate the two. And then if we really start to question what's underlying that, a lot of it are systems archetypes, which is not only are events happening that are interrelated, those start to become interrelated circles as well that create more complex dynamics. And so that's what we're going to look at tonight. Those are kind of more systems archetypes or structures. And then next week, we'll get into where did those even come from and look at one of the other disciplines of a learning organization, which is mental models. And we'll start to question our mental models, what's behind them. But one of the things that really impacted me the first time I dug into the fifth discipline many years ago when I was in grad school, and it makes more and more sense every year when I revisit and read it, is the different types of complexity. I hear my colleagues, and we are in the Industrial and Systems Engineering department here at UAH. And sometimes we kind of get segregated into industrial engineering, like me, worked in manufacturing, or systems engineering. But really, there's plenty of overlap. But I hear the term complex systems a lot. So I'm a simple guy, so I'm like, what does that even mean? But when we're really talking about complexity, there's two types. And it's important to understand the difference between the two. One type of complexity is detailed complexity. That's just something is more difficult simply because of the number of pieces. I grew up kind of poor, so I didn't have like Lego kits growing up. At best, I might have random pieces of Legos that mom would find at a yard sale, and you have to create something out of it. But in adulthood, I've learned to appreciate it, like any engineer. And my oldest niece, who's 26, got me interested the last 3 or 4 years in Formula One racing. And so a couple of years ago, we were collecting these little 4 or 5 piece Lego Formula One cars that you could get at the stores. And now we've both gotten into more complex 600 piece, 2,000 piece cars that have moving components and everything. And so they're a little more complex to put together than those initial 3 or 4 piece ones. But at the end of the day, it's about snapping stuff together. It's just a little harder. 1,000 piece jigsaw puzzle is a little harder than that 4 or 5 piece one that you get a child. But it's still putting pieces together in a pattern to make a picture, right? But then there's what we really want to start to understand and is harder to understand, and that is dynamic complexity. And dynamic complexity is when there's interrelationships between different pieces that may not be so obvious. But when you start tinkering with one variable, it has an impact on others that you may not have realized. And that requires a different, deeper, and broader way of viewing our environment. And I put this up there, supply chain for new vaccines. So way back around COVID, this was kind of funny. Literally 2 or 3 weeks. My first year in this department was academic year 2019-20. So not 1920, like the roaring 20s, 2019, 2020. And so fall or spring of 2020 was when the world shut down due to the COVID-19 virus. And right before that, like 2 or 3 weeks before March, and when our part of the planet got influenced enough to say, hey, let's shut everything down. The local news was wanting to understand supply chain dynamics of potential vaccines and supplies. It was medical supplies. People were buying toilet paper and causing all kinds of stuff, just like you experienced in the beer game. And so like they wanted somebody to interview. Somehow I got drafted to be interviewed by the local news. And so like I was talking about the bullwhip effect and how Oh, you go and panic buy toilet paper and what that causes all the way down back to the manufacturer and was talking about all of that. That's kind of complex, dynamic complexity. But then it got even more complex as the COVID pandemic grew and they started trying to distribute vaccines to different places. Because then it got really complicated, especially of the three types of vaccines. Everybody was just kind of wanting to blame. Well, why don't we just make more and get it to everybody? Obviously, like that's what we need to be doing. Just like in the beer game, we'll just make more. There's a lot that's going on there. One, they're just the ability to ramp up production to scale is a challenge. It doesn't happen instantaneously. If it does, it starts to put more of a strain on the construction industry. But then there was, okay, let's say we can make enough. What's all the supporting stuff that goes around it? Well, there was a certain type of glass vial that had to hold those, especially the ones that were made with the mRNA mix. Well, there was also like a shortage of sand and silicone and microchips going on that like compete for what was going to be able to make those glass vials. Then they had to be transported in coolers that were subarctic temperatures or it would fall apart. Well, you kind of need to have those and have transportation that can get those to different places, right? There were all these different variables in play that if you didn't understand all of that, it was really easy to scream and point at the TV and say, they're not making enough. Why don't you just make enough? But there's a lot more to it. So being able to step back and understand all of that is part of dynamic complexity. And so it's understanding that very often, almost always, reality does not happen in a straight line. It happens in interrelated circles, but then not just in one direction. We also have feedback and the ability to adjust. We also have to accept, just like we talked about with the beer game, and we said, I could look at it and say, my system is what I do, and I have no control over what customers order, and I have no control over when suppliers bring me stuff. All I can do is fill orders and order things from my supplier. And I'm a victim to not knowing what my customer wants and not knowing when my supplier is going to bring me what they have. But then we also looked at it in a different way and said, we're really part of that system because I can't have influence on my suppliers and build relationships. I can have better understanding of my customers' actions and behaviors if I dig a little deeper. And I view myself as part of the system, not a victim of the outside pieces. So identifying what those variables are and what variables influence which is very critical. And so that's the idea of systems thinking. And so there's the book introduces in chapter 5, I believe, the systems diagrams and systems thinking language to help us visualize how things are interrelated and how things influence each other. So I've got a saying, especially repeat it to my undergraduates a lot. And I always say, hey, we've spent 4 years, you made it to your senior year, and we, academia, has spent 4 years absolutely ruining you. And now we've got 1 year to fix it. Remember me saying this part? And one of the things I always talk about is one thing that you realize when you get out into the real world, and many of the students have already had internships, some haven't, but like we try to have senior design projects at real companies where if even you haven't, you're getting some kind of experience to the real world. And the experience is about what happens more than it is what you actually implement. It's understanding that things change and that you may not get implemented what you want. That's just as important as actually implementing technical stuff. But one thing that I always repeat is that the givens are never given. We're given in engineering in academia problems, given that X is between this and this, and given this, execute this tool and give me an answer. And we learn and we practice to execute our formulas, our equations, whatever it is, given a set of parameters. Then when you get into the real world, the givens are never given. You have to determine them on your own. So I can know how to use some set of technical tools or equations or systems, and I can execute it perfectly. But if I'm executing it perfectly under the wrong set of givens, a lot of bad decisions and a lot of bad consequences can happen. So identifying what the variables are yourself. I mean, this is what critical thinking is and why it's so important, because life is about determining what your own givens are, because you're not going to be given them. Determine what are the variables and what are the ranges that are at play in this environment that I'm in, which ones influence each other and by how much. And if you can do that, then okay, the solutions, the problem solving, all those things you actually learn in engineering, you can apply. But if you're not applying them and you're not thinking and understanding the variables and how they influence, you might not be applying them in the right place. So that's the idea of systems thinking. So he uses a very simple example to demonstrate the difference in linear cause and effect and identifying what a circular system might look like. And I relate to this very well, maybe y'all do too. Like I traveled a lot the first 19 years of my professional career. I was always, more weeks than not, I was always somewhere new. And with that came hotel rooms, which came with their own way of how showers operate. So there was always tricks to that. Trying to figure out what controls the temperature. Some has two knobs, some has one, some have a handle, and you turn them different ways. Some, no matter how hot you try to make it, it stops you and says, we don't want you to be happy. We want you to have to take lukewarm showers. So you can view that as I turn a handle, temperature changes, or you can view it as it's actually a whole system. So I was talking about temperature. He talked about filling a glass of water. You have a desired water level. My goal is to fill the glass, and that desired water level influences the perceived gap in is that glass full or not. Because I can have, what's the old saying? Glasses half empty or half full. If my desired water level will dictate what the current level is versus the gap in filling it. And then based on that perceived gap, I'm going to take some action. And I'm going to adjust the faucet to either increase or decrease the flow of water, which changes the water flow, which gives me a new water level that changes my perceived gap, and I can compare that back to the desired water level. So identifying what are the variables that affect my desired water level. It's the turning of the faucet. And I have to understand that why I'm turning it, actually because I'm increasing or decreasing the water flow. That's why it's important. That has an influence on it. And it's that water flow that changes the water level. So that's something very, very simple. But learning to frame even that into what variables actually go into filling my water. It's not just turning the handle, it's because the handle opens a valve and controls the flow. So that's the general idea of learning to see things in loops. So then there's a couple of different types of feedback loops that they introduce. One is the reinforcing loop, which means the goal of this loop is to continue to gain momentum, either growing or declining. In other words, getting momentum in the increasing level or consistent momentum in the decreasing level. So here's an example of a reinforcing loop. I did most of my career was helping companies implement lean production systems. So I'd go and I would work with companies. And so if the company's desire is to implement a lean production system, that means two things: having a way to do continuous improvement to your processes and having an organizational culture that shows respect for people. Like, that is the Toyota way fundamental values, which is what the lean production system is based on. So if you as a company desire to do that, I would always tell the first thing that you have to do to develop continuous improvement and respect for people is you have to invest in both of those as an organization. You can't just say, I want them. You have to invest time, money, resources into doing it. So you have to invest in continuous improvement, but also in employee development. Understand that both of those are important. And if you do, there is a good chance that you will see improved results, increasing quality, improvement in cost of what you're doing, and be able to deliver on time. And if you're doing those three things as an organization, I'm doing things better, I'm increase my quality, cost, I'm able to compete at a lower cost. It costs me less as an organization to do it, and I can get it to you quicker than the competitors, then I'm probably going to have customer satisfaction, which will grow to my business. And when I grow my business, all of a sudden I have more resources to invest to continue to improve my processes and develop my people. So the more I do that, the more momentum I can build. And that's called a reinforcing loop. And so the symbol that the fifth discipline uses for a reinforcing loop is just a snowball rolling downhill to show that we're trying to build momentum, not that we're trying to go down all the time. Because it can also work in the opposite direction. I could also not choose to invest or stop investing. Then my results would go down. And if my quality dips, my delivery dips, my customer satisfaction is going to dip. I'm going to start losing business. Then I have less resources to invest. So it can be a positive or a negative. Either way, those are reinforcing loops because the different variables that influence each other keep the loop going. So we see those in life. We even in our language talk about it, right? The snowball effect, the symbol that they actually use is there. But in systems thinking in the fifth discipline, he says, do we actually ever stop to try and understand what those variables are and how they are affecting each other? I use an article when I'm talking about organizational culture change. I think we introduced this in EM 660 for those of you that took that class with me, called How to Change a Culture, the story of NUMMI, the New United Motor Manufacturing Incorporated. It was a joint venture about Toyota and General Motors in the 1980s, where Toyota took over General Motors' worst plant. They were actually shutting it down and said, we'll keep your employees in the same facility under our management principles. And in a year, it went from the worst performing plant for General Motors that was about to be shut down to its highest performing. And the article that was written by a guy named John Shook, who was an engineer working for Toyota at the time, involved in that project, we talked about the culture change that happened. And he said the culture change that happened did not happen because a company said, we're going to do this, and expect behavior to change. In other words, I've worked with companies implementing lean systems, and this is just one example of a system. And they would call us in and they would say, Nick, we want to do lean system, but then they wouldn't actually change their behavior of how they did things and expect the results just because they had read the book of what the typical results of a lean system is supposed to be. They'd say, hey, we put the banner up in the break room, we bought everybody t-shirts, we're doing this, but then behavior never changed. But in the NUMMI article, John Shook said, a change in mindset does not lead to a change in behavior. You shouldn't expect people's behavior to change just because you say you're doing something different. But if you change your behavior and are consistent and develop different habits, it will change the mindset because it just becomes the new way that you do things. Then the other type of loop that we see is balancing loops. So where the intent of a reinforcing loop is to keep momentum going one direction or the other. In a balancing loop, what happens is the forces that are acting, the variables that are interacting, cause things to become stable, not increase or decrease. They're adjusting to keep the situation stable. And in the fifth discipline, he actually says all reinforcing loops, positive or negative, at some point there is some force in nature that is a natural check that starts to try and balance that. We see that in politics all the time. If people take one shift, then usually in the next cycle it goes so bad that we see another shift that say, okay, that's enough, let's balance it out. And we see it in all aspects. So in a balancing loop, we're trying to keep things consistent. So the example there is, let's say I'm trying to drive the speed limit. I'm trying to drive a consistent speed. I'm not trying to increase or decrease speed. I'm trying to stay at a steady rate. So my desired driving speed, the speed limit, however I define that, whether it's the speed limit on the sign or it's the, hey, I get plus 10 miles an hour or whatever's on the sign, whatever my desired driving speed is, influences. So anytime we see an arrow, it's good in our brain to say influences. My desired driving speed influences my perceived gap in speed. I want to be going 70 miles an hour. I'm going 65. The gap in speed is 5 miles an hour. Slower. And then my perception of the gap in speed influences my decision to either accelerate to increase speed or decelerate to decrease speed. And then that will then influence my new driving speed. I want to go 70 miles an hour. Desired driving speed, that influences the gap in speed. I'm going 65. That means I need to accelerate to get from 65 to 70. And then that will influence my new speed, whatever that might be when I accelerate, which will change my perception in the gap in speed. So if I accelerate and I go to 71, then, I need to back off a little and start to adjust. Or if I want to outsource that to cruise control, that's what it's going to do. So the symbol for the balancing loop is the scale that we're trying to keep the situation stable. So all the forces are acting, but they're acting to make it look like nothing's acting. I always say that about a house. I always say, if you understand structure, if you understand statics, you understand that it takes a lot of effort to make it look like nothing's moving. A lot of things are subtly moving to make it look like nothing's moving. Design a truss, all those things are there to push up against each other. And if everything's great, it takes less force to make it look like nothing's moving, but there's subtle movements to do that we don't see. That becomes compromised and there's pieces of that truss that are broken. The forces start to strain. It may still look like there's nothing moving, but there's a lot more effort that has to make it. Same thing's going on with the balancing. And here's where I was getting ahead of myself and talking about the water and the temperature in the hotel room. Understanding the variables, then the arrows, which are the influences, and then the two types of circles, reinforcing loop, balancing loop. Then the most critical, or the other critical thing in systems diagram, is delays. Understanding the delays between when a cause happens and its effect. So water temperature. I want the water to be warmer. I'm running the water to see if it gets to an ideal temperature before I jump in the shower because I don't want to freeze. Here in Alabama, this time of year, it takes a little longer in my house for the water to get through the cold pipes to get up to a temperature that I want. So I have a desired water temperature, whatever it might be. And that desired water temperature influences my perception of the gap in temperature based on what I'm feeling. So then what does that do? If it's colder than my desired water temperature, what action do I take? Turn the water tap to the setting closer. Okay, I want it to be warmer. I'm turning it toward warmer. And the water will warm up, right? And as it starts to warm up, it changes my perception of the current water temperature. And then that kind of closes the loop until I get it to where I want. But here's what happens sometimes, right? That's a balancing loop. But the minute I turn the water tap, it doesn't instantly always change the water temperature. So what happens? I turn it to be warmer. By the time the water tap is in the position for it to be my desired temperature, very often I've turned it past, right? Because there was a delay from when it reached the right temperature to the time I felt the right temperature. And by the time I felt it, I had already taken an action. That then what happens? Goes further. And then a few seconds later, what happens? Gets a lot hotter because the temperature I wanted was back here, but I didn't feel it till later and I kept turning. Then by the time I feel what I like, I've turned further. So even if I stop turning it, it reaches the temperature of where I turn further and it scalds me. So then what do I do? Violently turn it back to the cold side, right? So depending on how long that delay is, I'd probably turn it more rapidly back the other direction. So that's a really good way, in my mind, of explaining the role that delays play in systems diagrams. So when you're reading a systems diagram, you state the variable, my desired water temperature. Then anytime you see an arrow in your head, say the word influences. My desired water temperature influences my perceived gap in temperature, which influences if I turn the water tap setting, which direction. And then if there's a delay, add the word eventually. I turn the water tap setting and eventually it will reach my current water temperature, but not immediately. So just like in the beer game, delays played a huge role because there was a lead time from when I ordered something to when I was going to receive that from the supplier. Oh, there's a 2-week lead time. My customer demand went up, so I'm going to increase my order as well from my supplier. But understanding that it's going to be at least 2 weeks before I get the higher order, and I've already had to fill my customers' higher orders. And then they may come in the next week and still order higher. So then I order higher again because I haven't received from my supplier. And the longer that delay is, the greater the chance of me forgetting that I'd ordered a whole bunch. And then it all starts to show up later. but I'm still ordering at a high level. So for those of you that took EM 660, let's go all the way back to whenever you did. And we talked about the 3 Ps and how they interrelate within an industrial revolution to eventually influence another. The 3 Ps were processes and technology, people aspects, and management principles. So we introduced in the first industrial revolution processes and technologies. I was just talking about this Tuesday in EM 660 to that class. There was the mechanization, the automation of the textile factory in the mid-1700s when the first industrial revolution kicked off, and that was the largest industry in Great Britain. And all of a sudden, there was a wave of technologies that automated weaving and spinning and greatly increased productivity in textile production. Increased productivity, made it more affordable, made it more accessible to more people, made demand go up, which made people start building factories, and which means we need more steel, and we need better transportation, which means we need more steel, which the steam engine came along, and we needed coal for the steam engine, and we needed steam engine to get more coal, and all these things magically happened at once, and we had all these processes and technologies that brought about a new way of living. But we also learned that that introduction in processes and technologies eventually, not immediately, had effects on the people aspects of society. We had people going from 80% of the population was a agrarian, agriculture-based society to, and that had been that way for hundreds of years, to the span of less than 100 years. They completely flip-flopping and people moving to the cities and working in factories. Standard of living went down, then it eventually went up. Changed the way education was done. And we also saw resistance. A group of folks called the Luddites, who were master weavers. And when there were machines that came along to replace them, they said, not on my watch. I'm going to break into your factory and break your machine, because I'm threatened by this new technology that's going to replace me. So we introduce technologies, then society reacts. And ultimately, the people aspects, due to the Luddites acting out, led to new laws and regulations. They introduced something called the Frame Breaking Act that says, oh, I didn't know we needed to do this, but now we're going to make the act of breaking into factories and damaging machines punishable by death or permanent relocation. We have now, societal reaction has influenced public law. That'll put a stop to it. We introduced all these technologies. The thirst to be more productive led to the factory systems. Then when the factory systems happened, we had people showing up to work in a centralized place instead of taking work home like they did in the cottage industries. We saw a lot of dynamics, but one of those was when we're bringing people to work, how long do we work? As long as we want, apparently. Oh, bring your wife too and your kids. Let's make it a family affair. We'll have everybody working 12, 16 hours a day, no breaks. Then along all of that eventually led to a series of laws called the Factory Acts. Hey, maybe we need to limit how long we're working people, especially kids, and maybe we shouldn't send kids under machines to do maintenance just because they have little smaller skinnier fingers. Like we need kind of, those laws came about because of the people aspects that happened because of the processes and technologies, and those became the guidelines around which we started to engineer and design new processes and technologies for the next 100 years. So now we've got new guidelines we have. Again, just like if you're engineers and you're focused on something in electric vehicles, I'm around the automotive industry a lot, especially 5 years ago or so. There's laws, there's regulations, there's incentives that drive engineering efforts, whether I believe in it or not, toward electric vehicles. Like that framed what I'm engineering. And then that's the next wave of technologies, which influences the people aspects. But that's 100-year cycle that we saw in the first industrial revolution. 100 years between industrial revolution number 1 and number 2. And the further those things go, the harder it is until you look back in history and start to look at it. Because there was such a delay, we introduced these technologies that didn't immediately cause all of this stuff. The mechanizations of the loom started being introduced in the 1760s. The Luddite Rebellion happened in 1811. Took time. So understanding those delays will help us possibly understand, oh, when I introduce this, there's a chance it may change society this way. It's not going to happen immediately. So when it doesn't happen next month, you can't say, I told you so, that wouldn't lead to this. But understanding the delays in the system and what they might lead to can help us possibly predict in the future and make better decisions. So applying systems thinking not only to the design phase, but just in society and how we view things in general. That's why Industry 4.0, the fourth industrial revolution or beyond, like a lot of people are like, oh, they've already jumped to Industry 5.0, whatever. And so like the way I define it, I'm like, maybe we're still introducing new technologies, but we've not seen this full loop happen yet to say we're in some new kind of industrial revolution. But that's also hard to define until like you reflect back in history too. It's hard to see when you're in the middle of it. But if we can learn to see it a little more clearly while we're in the middle of it, maybe we can be more proactive. That's the idea, right? So the introduction of this stuff is the reinforcing loop, that was one, the balancing loop, and the delays. Those are 3 components of individual systems diagrams. And so in the language of systems thinking, as the 5th discipline explains it, those are like the nouns and the verbs. Those are words. But those loops in themselves, that gives us a little better understanding, but we also need to understand that those start to act together. I put nouns and verbs together that start to make sentences. And those words influence each other, and then sentences influence other sentences and paragraphs. And if we can start to understand all of that, then maybe we can understand complex systems a little better. So in chapters 6 and 7, and then expanding upon that, there's an appendix of systems archetypes. And so what systems archetypes are interactions of some mix of those 3 words, nouns, and verbs, reinforcing loops, balancing loops, or delays, interactions of those 3 to form different types of sentences or archetypes that you may notice happen naturally in general in nature. And if we can learn to see them, maybe it can give us a better understanding and drive decision. So he introduces 2 of them in chapter 6 and 7 and talks about them. But then there's about 11 or so, I can't remember exactly, archetypes in one of the appendices that just say, here are natural things that happen in nature if we can learn to see them. So last week, I think it was, when I was introducing some of the different create tools to use during the ideation phase of innovation engineering, we talked about one of the tools called TRIZ. And that was the one where the Soviet naval officer went in and he looked at like 40,000 patents. And he looked at all these specific detailed patents and he said, you know what? I've recognized some consistencies here, that there's 39 different elements that could have contradictions. I want to increase speed without decreasing size. That's a contradiction, or whatever. And we looked at that. And then he identified 40 principles that had been applied to resolve those contradictions. And so then develop potential solutions using those principles to resolve these contradictions. So basically, it took a specific problem, resolved it into a generic problem, which led to a generic solution. And then you can say, how can I take that generic solution and create a specific one from my world? So archetypes are those generic things that happen. That if you can start understanding them and applying them to your specific situations, then it helps us to understand the dynamics of what's going on, dynamic complexity, but it also tells us where to best apply leverage. So now going back to statics and dynamics, probably will not reference them in class near as much as I have tonight ever again. But leverage is distance and force. I think I used this example the first or second day of class. I was talking about opening a door that has a bar. And if you have the hinges, you have the door with the bar on it that opens. If you push on the bar close to the hinge, how much force do you have to open the door? Kind of hard, right? Maybe impossible. I've seen some people like hit the wrong side and then power through it, which I'm not going to admit. Because it's short distance, has to have a lot of force. But you can have the same leverage with less force at a further distance. The distance time force is the same to open the door, but you have less force at a further distance, and that's called leverage. So there are some efforts that you can apply in a situation that you have to put a lot of effort in to get very little impact. I'm pushing as hard as I can on the hinge side of the door handle, and I'm really not getting a lot of results. But there's other actions that you can take if you understand the dynamics that take less effort but give you more leverage and get bigger. So learning where to apply those is important. So we'll look at some examples of that, starting with the systems archetype of limits to growth. So just like I mentioned when I was introducing the individual loops, the reinforcing loop and the balancing loop, I said nothing rarely constantly grows or declines without some balancing act in nature checking it at some point. And so a limits to growth archetype contains two things. It contains a reinforcing loop, but then it also contains a separate balancing loop that slows that reinforcing loop down. And the way to gain leverage in a limits to growth archetype is to understand what the slowing action is. If you want to continue having this reinforcing loop grow, but there's a natural balancing loop that limits it, understand what slowing action there is and try to limit that condition instead of trying to push harder on the reinforcing loop side. Because I can put a lot of effort into just doing things harder without understanding what's slowing me down. Or I could understand what's slowing me down and apply leverage there to keep the reinforcing. So here's an example of that. Again, going back to some of the things I did in my life, Kaizen activity is working with a team of people in Lean to make improvements. And this is another lesson I try to share with my undergrads is trust the problem-solving process by working with the people who do the job to learn to see waste and make improvements. Don't feel like you have to go and fix everything yourself. Work with the people who do the job. And that's called employee engagement. Involve the people doing the job in the Kaizen activity. Kaizen means good change. process improvement. If you involve them in the job, not only are you probably going to get better ideas, and this is something I learned early in my career. It's like, even if I had the best idea in the world, if I'm going out and trying to apply it in someone else's job, and I do it without involving them, the chances of getting buy-in are pretty low. Whereas if I do engage them, we work together, we probably come up with a better solution, but I also have buy-in and I've helped polish that person's problem-solving skills, which leads to better and more employee engagement. I saw this all the time when I would go to a company and work with them for the first time. Employees would be reluctant to work and give ideas. Some of the people would even kind of poke fun at them. Oh, you're doing that over there. Then when we did the activity, when we saw the improvement, we got buy-in, then all of a sudden it's like, hey, I want y'all to do that over here, and people wanting to be involved, and you get a lot of them. That's a reinforcement. But here's an observation I make and saw over and over and over again. We've empowered employees. They're part of making changes. We're getting a lot of positive momentum. But eventually, the management that existed, especially in middle management, had a way that they traditionally led that all of a sudden didn't quite make as much sense with an engaged, empowered workforce. If you remember in EM 660, we talked about Douglas McGregor, and he had Theory X, Theory Y management assumptions. And he said, you might can get away with Theory X management assumptions. I assume people are lazy, do as I say. And when people are lower on Maslow's hierarchy or in the older days of scientific management, but as people got more involved in work and expected to be tap into their knowledge more at work, that management style wasn't effective, and maybe a Theory Y management style, an assumption of people want to be engaged, that want to be active at work, is more effective. But if traditional management didn't change, there would always be an uncomfortable feeling that wasn't explicit. They didn't now say, stop doing this. But because they became uncomfortable and didn't know how to manage an empowered workforce when they were used to someone saying or doing something just because they said so, they would revert back to that behavior, which would slow the employee engagement, which would slow the Kaizen activity, lessen the buy-in, and stop the growing action. So that's an example of a limits to growth. The limit to growth in this case, and you have to be savvy to learn to see it, which is why I think it's important to learn to draw these diagrams. Is to learn to identify the slowing action, which in that case is the traditional management style. So then our systems archetype says the most leverage can be in focusing on that slowing action, not trying to do the reinforcing link part. So the leverage is there. So what do? How can we give them new management skills? How can we increase their comfort level? How can we better define what that person's role is supposed to be and give them training and develop them to be able to do that so that they're more comfortable with it, so they stop discouraging employee engagement, so we can continue having buy-in and keep the reinforcing loop going. And again, these are subtle things to see. There's delays, because what would happen is there was these people, when you would go in and get initial momentum, it was like, I love this. Then when it almost becomes self-sustaining, their management style used to be do it because I said so, and now all of a sudden we've empowered people and that's running, and they're not quite sure how to manage an empowered workforce, but they didn't realize that for a while. Then they started having to say, I need to force these people back into what was working on my management style, where the leverage can come into how do we develop you to where you're more comfortable doing the management style and seeing it to sustain this new way that we're trying to do things. That's just one example, but if we can start to identify that limits to growth archetype happens in a lot of different places. And understanding that the leverage to keep the growth going is not in trying to grow faster and harder, but understanding the slowing action and taking action there. And that's what gives us the leverage. And the other major archetype that was discussed was shifting the burden, which is two balancing loops. But it was the difference in a problem symptom, but then two types of solutions. One that's a systematic solution, the quick, easy fix. One is a fundamental solution, which is a longer term root cause fix, but it takes longer. And if I don't focus on the fundamental solution and I only focus on the symptomatic solution, very often I get addicted to that symptomatic solution, which creates a reinforcing loop of me needing to do that symptomatic solution more. And so I will go back to my world again. A lot of my world was spent, especially the first half of it, going out and facilitating Kaizen events, facilitating teams of people in improving a focused project. So they would hire me, Nick, from Alabama with a funny accent, come in, work with our people, come up with improvements. And we would. I would be the outside lean guy. I would come in to fix this need of Kaizen facilitation. And we would work with teams that would fit that need. But they were reliant on an outside person coming and doing it. And I would never forget one of the perils of doing that. And I always told companies when I would go in and work with them, because I wasn't a private consultant. I was doing this through funding at the university. And I always go in and I would say, my job, I'm trying to get you to where you're not dependent on me and work myself out of a job. What does that mean? It means we need to develop the skills of what you're bringing me in to do within your own workforce to address this need of Kaizen facilitation or teams making improvements. I would come in, I would facilitate it. But I'll never forget, I was working on a company in Colorado, and we had gone in and did a Kaizen event with that company and had a lot of success. And it was the first one we had done. And we had some action items that needed to be implemented as follow-up. We did a lot of things, and we said we need to do these few things that we didn't get done during the week. We need to have it in place. And we went back weeks later, 4 or 6 weeks later, to do a project in another area. But I remember walking by the area we did the project, and they had some of those things in place that were part of the follow-up items. And I was like, hey, that's really cool. Y'all got that, and you're actually using it. And they said they put that in earlier this week because they knew y'all were. It's like, if you're doing it for my sake, I don't care, man. I'm not working here. But if you're dependent on me and it's not institutionalized, you're not really developing what you need to make this work. So that's the systematic response is let's bring somebody from the outside in to do it, and we only do it while they're here. Whereas if I truly have this need, Kaizen facilitation, which every company does, they know it or not, the need to continuously improve by eliminating waste. It would take longer, there would be a delay, but the fundamental solution would be is if I develop my managers in the organization and added the role of facilitating Kaizen to them and train them to do it. And most companies would say, yeah, they're too busy. We don't have time. Can y'all just come do it for us? Yes, short-term symptom, get addicted to it. It may take longer, delay, but if we develop the managers as facilitators, then you have that ability of your own. And the fundamental solution gives you much more leverage than being dependent on the outside source, which is the symptomatic solution. And so it becomes a reinforcing loop. The more dependent you get on the systematic solution, It gets worse. So learning to see that, that's called the shifting the burden archetype. So being able to see, so the new systems language, the causal loops, which were the reinforcing loop, the balancing loop, and the delays. Those three components are the nouns and the verbs. Then the archetypes are, we're putting those together into sentences. Now we just saw a reinforcing loop interacting with a balancing loop to give us the limits to growth archetype. We just saw two balancing loops interacting with a symptomatic solution versus a fundamental solution. Now reliance on the symptomatic solution becoming its own larger reinforcing loop. If I can learn to see those, then I can understand dynamic complexity a little more. So detailed complexity is just the number of trees in the forest, but dynamic complexity is understanding why the forest exists. So then the last piece of that, good luck. The last piece of that is, now guess what? Those archetypes interact with each other too. So just like the feedback loops are an interaction of variables, and the archetypes are an interaction of the feedback loops, those archetypes interact together too to make the world even more complex. So if we can learn to see all of it, the better we can be. So let's say I have this reinforcing loop. I have a desire for more revenue. So to get more revenue, I'm going to increase the size of my sales force, which is frightening if you think about the world with more sales. And if I increase the size of the sales force, I may see the number of orders go up. That influences the number of orders, which influences the revenue, which means I want even more salespeople, which influences the number of orders, which influences the revenue. And that on its own is a reinforcing loop. But just like we said, for every reinforcing loop, at some point in nature, there's going to be a balancing force. So in this case, I've increased sales so much and gotten so many orders that now we have a backlog. We can't keep up with our existing resources. Sales, yeah, you did such a great job without understanding our capacity that you've went out and sold stuff that we don't have the ability to do. We saw this in our engineering management program. Not so much revenue, but hey, we want in the PhD program specifically, but the engineering management program in general. Restarted it in 2019. Hired me, one faculty member in the department. Started getting the curriculum out, started getting more students. Enrollment goes up. Did not increase the size of faculty. Then all of a sudden we start to get more students, then it's hard to work with them. I have more PhD students than the other 8 faculty combined last semester. Guess how responsive I was able to be? Not very. So then all of a sudden there's a backlog, which negatively influences delivery time. Now we can't get your orders to you because we're so far behind. And eventually that leaves a sour taste in people's mouth, and what used to potentially be an advantage all of a sudden is a disadvantage, and sales start to go down. And when sales go down, that influences the number of orders to be less, which influences the amount of revenue to be less, which influences the size of the sales force. We need to downsize, and eventually it starts to balance. Then there's more than that. I could look at that and say, I see that that's happening. I need to do something. The delivery time is what's influencing the sales decline. In this case, we made so many orders that we got a backlog and we can't deliver our customers, and that's making them mad and sales has come down. But if I could just keep delivering on time to my customers, and then maybe we could keep the reinforcing loop going. So that's my need to improve delivery time. But I can't do that immediately. I need to increase capacity to do that. We need to add more production lots, just like in the beer game. When demand goes up, eventually at some point, as the retailer, I'm increasing my orders to the wholesaler, who then increases the orders to the distributor, who ultimately increases their orders to the brewery, who at some point had to increase their ability to brew more. And there's a good chance that wasn't just an instantaneous, let me turn the knob. It was, we need to get more capacity, build new facilities, get more boilers, whatever they needed, twice the ingredients. That's going to take a while, but eventually, if we plan to add capacity, we'll increase production capacity. And then theoretically, if we do that, we can deliver on time, which stops the sales from declining, which allows our orders to go back up, keep revenue going. And so now we've gone from variables to variables interacting with each other with feedback loops to feedback loops interacting with each other to cause archetypes. This is our reinforcing loop combined with a balancing loop to cause limit of growth. There's a delay in there, but then we have another limit of growth to try and deal with. We have the symptomatic solution and the fundamental solution. But the fundamental solution usually takes longer and more patience. And the leverage is delivery time standard potential. If I work with sales and I give a more realistic delivery time standard instead of tomorrow, even though we have an increased capacity, if I do that in the short term, and I also have plans to add capacity to get delivery back, those are two places that I can place leverage. And guess what? We're going to learn this more in Module 2. Communication of delivery standards, long-term plans, those are what go into strategy. Me as an organization, guess who gets to determine the message to my customers of what our delivery time standard is? I do. I get to make that part of my strategy. When I'm planning for strategy 3 to 5 years down the road, guess what I get to do? Try to look down the road and have plans to add capacity into my long-term plan. We're going to do this, and it's probably going to lead to this. So we're going to go ahead and start planning to grow here. So the better we can think strategically, the better we can foresee these things and how they can lead to the big picture, the greater the chance we have strategic success. So the more we can understand complex, dynamic complexity versus deeper complexity, the better. But it's difficult. So strategy is hard. So fun stuff. You'll get to practice drawing feedback loops. I sketch these out a lot of times when I'm trying to understand things that's going on. I like still to this day. I find it very effective. Over the next couple of weeks, we're going to introduce the other 2 books. One of them is Getting the Right Things Done. I'm just kind of give you an overview. If you follow the readings, I think doing the first chapter or so as part of this week, but it was just to give you a head start and spread the readings out. But what Getting the Right Things Done is going to do is introduce us to a company called Atlas Industries. It was a company that had implemented lean concepts as pieces, not as a whole, and they were about to go out of business. The CEO was actually looking at selling the company, but then he hired a COO with a lean background who introduces strategic planning. And through that, they kind of follow them. It's in a novel form, so you get introduced to characters and a story while it's introducing the strategic planning process. And you get to see it's not just a perfect story, like they've had challenges along the way, and they don't implement it in the ideal way. So there's a lot that you can learn from it. So whereas the 5th Discipline is a very heavy theoretical type book, this is kind of completely the opposite. But I like the way it teaches certain things. So go ahead and get yourself familiar with that. And then a book that I started using last year in this course, When They Win, You Win. We'll introduce it next week as part of mental models, but then it'll really drive a lot of, it'll be a part of both modules 2 and a big part of module 3 when we get to strategic leadership. I don't enjoy reading, so if I do read things, I hope they're good. I don't give books. I intentionally choose the books I assign for class in hopes that they're things that you hold on to and find valuable as you go into your career as an engineering manager. This is one of them. Russ Laraway was a leader at Google, actually worked with Kim Scott from Radical Candor. So if you like Radical Candor, there's a good chance you'll like this book. I actually have grown to like this book even more because he talks about how to become an effective manager. For in engineering management, there's a fair chance that you have aspirations to become a more effective manager. Because effective managers, which are the big, and he introduces 3 big things that make someone an effective manager. The ability to give direction. We learned that in Radical Candor, right? Giving and receiving feedback. The ability to coach and the ability to develop someone throughout their career is how he defines being an effective manager. The big 3, which leads to engagement. And only without engagement should we expect to get results. And they have some numbers to back that up in the book, and there's a lot of cool tools and things that we can learn to make us better leaders and managers. But I think I introduced chapter 2 of each of those 2 other books to start getting used to them because they're going to start bleeding into our curriculum for the next weeks. Next week, we're going to talk about mental models, which is another one of the 5 disciplines of a learning organization. And this is a good example of a mental model of how to view being an effective manager. If I do these 3 things, it'll lead to engagement, which will lead to results. If I can adapt that mental model, maybe that'll drive my life. And we'll study what that means a little more. How are you doing? You have any questions? Comments? It's just fun stuff. Like I said, the 5th discipline can be a little heavy and monotonous, but like there's so much good in it. Like I said, every year I have to revisit. It's like, oh, I get that even more. It's way ahead. I'm glad that we can.
So the plans,
Yeah.